Hello, good afternoon. Welcome. This is Junichiro Horikawa, and this is a Houdini tutorial live stream for this week. Okay, and this is 145th episode. Today I'm going to try to create some simple hard surface shape. In this case a crystal shape, with some gradient textures on its surface using Copernicus. So the main topic here today is first of all creating a hard surface geometry procedurally using Houdini. Doesn't really have to be a crystal, but something looks hard as a surface, and also using Copernicus to create a textures on its surface. In this case, a different gradient textures on each surface, just using single COP network. Okay, and also trying out some stippling for these gradient textures, something like these, like stippling effect. To make it more like a graphic-like style. Okay, so this is because there's one project that I'm working on which might uses these techniques, so I was practicing it if I can do it on Copernicus, and I just wanted to share those findings while I learned these steps. Okay, so hopefully you'll found it interesting or helpful in some way. In the end of the live stream, I will share the files that I've created on the live, as always, so you can play it out with it. Okay, so as always, I'm just going to start from scratch to just show you all the steps that I am going to use. Okay, so first thing first, I am going to create a hard surface geometry, which in this case it looks like, let me just show the examples. So in this case, looks like these shape. Okay, as an example, I prepared a crystal shape, but doesn't really have to be crystal, it could be any shape. So the first setup that I'm going to create is to create this procedural setup to make an input geometry a hard surface, like something like these. Okay, the line that you see here is a split line of vertices. Okay, so let's do that. So first thing first, before getting into an actual crystal shape, I'm going to prepare some simple shape in order to make a hard surface. I'm gonna start with some sphere with some resolutions and make the shim randomize a little bit. So the idea for the hard surface is based on the idea that I saw on Akira Saito-san's video in Houdini Hive. That was an year or 2 years ago, I think, which showed some ideas how you can make a hard surface out of a geometry. It didn't really show the specific method, but I from the idea that I saw on that video, I'm going to trying to replicate the effect that he was doing. I think it's a bit different, but something similar. Okay, so prepare some geometries, something like this. Let's say I want to create a hard surface out of these, out of this geometry. Okay. The first thing you want to do is to create a initial, initial like splitting, initial edge, hard edges onto this geometry. Okay. What I will do, first of all, do a remeshing to reduce the number of faces as much as possible, so that it will have less number of hard edges as possible. Okay, so let's say 0.25 or something like that. Let me also make the background darker, and also let me save this just in case I don't lose the I don't lose the save the lose the progress, since unfortunately using Copernicus makes you like crash a lot of times. I mean, I experienced this crashing while using the Copernicus side like more than 10 times. So hopefully that will be fixed in the future update. But for now, I gotta make sure I save this frequently. Okay, so let's save this as okay. So after I have remeshed, the important thing is to decide the threshold for the hard edge. Now I'm going to do that by first of all using a normal node with the vertex option. Also, if you're here and if you can hear me, let me know. I'm not sure if the sound is on. Well, hopefully it is. Okay, and using normal, you can change these values for cusp angles. Thank you, Alan. You can choose this cusp angle to show which edge will be used for the hard edge. And you can also turn on the actual hard edge line by clicking this button, display 3D island boundaries, and currently there are no boundaries. This normal doesn't really cut the mesh itself, it just displays it as a hard edge. So once you made the normal for the vertices and decide the threshold where you want to make the edge harder, you can now use a node called vertex split, which uses the vertex normal to actually cut the mesh at the hard edge position like that. Okay, so this will going to be the initial initial hard edge positions for this mesh with the threshold that I chose here, and you can control it by changing these sliders. Okay, so next thing I want to do is to clean these edges up a little bit, because it seems like there's too many edges around, too many edges that seems unnecessary. For example, even though these mesh is one continuous mesh, you still have these split lines across all over the places like these. So what I want to do is to clean this up so that I can remove those edges that are crossing if you want to make the surface as singular, like clean face without any inner edge. So I want to how do I say, dissolve these inner edges, inner hard edges somehow. So to do that, what I'm going to do is to use a assemble node plus enabling this piece attribute. I'm going to call this class, and which will give you a primitive attribute to each faces, which face belongs to which class or which island. Okay, so now that I have these informations, I'm going to promote this class information to point, class attribute to point attribute, primitive to point, and use that to dissolve those edges, so those inner edges. Okay, to do that, I am going to use a attribute promote. So bring the primitive class to point class. Maybe keep the original, might be useful. And after doing that, you'll have these class on the point. Now use the fuse node, and what I'm gonna do is to fuse only when the class attribute matches. So do the fusing or weld the points only if you share the same class attributes. In this case, I'm going to turn on this match attribute, change this to class. As a result, if the points is on the same island, it will try to fuse the point, which in the end will dissolve all the inner edges and gives you just the outline of the geometry, and will give you some clean hard surface edge like these. Okay, cleaner than previous, like that. So if you compare, this is the previous version and this is the current version, looks better a little bit. Yeah, let me also go back to the normal threshold and gives a little bit of higher value so that I have less edge lines. Okay, so maybe this is cool. Okay, so next thing I would like to do is to smoothen out the hard edge. Currently it's a bit jaggy here, something like these or something like these here. The edge is a bit too how do I say too polygonish, to not too smooth enough. So I want to make these curves smooth enough to make the final shape a bit nicer. Okay, so to do that, first of all, I am going to remesh this geometry to create a bunch of additional meshes from here. So do the remesh with smaller edge lengths. Previously it was something like 0.25. Let's make it smaller than that, like this. So you have more edges, and now you have enough edge points to make these edges a bit smoother. Okay, you can make this small as possible, but I'm gonna go with 0.1 for now. Okay, let's save this. Okay, and what I am going to do next is to what I'm gonna do is to recursively get the edge informations, from these polygons, just smoothen out these edge as it is, and update the surface positions based on the updated edge, smoothed edge positions. And that's what I'm going to try. So I think it needs to be looped, but we'll try without the loop for the first attempt. So I'm gonna connect this to null so that you know where to break the part. Okay, now to get the edge information, just the edge informations, I first need to dissolve the inner edges. I'm going to use a divide node. Check remove shared edges so that you can get the outline like these. Let's fuse this and make it to convert it into line like this. Now that you have these informations, it's more easier for you to make it smoother. In this case, if you're just okay just smoothing this as it is, you can use smooth node. Will enable you to make the edge smoother. You can also create some conditions in terms of the number of connections and number of neighbors you have on the points, like to make it smoother or not. Maybe in this case, if you go back to the mesh geometry, the original mesh geometry, maybe if you have a point connections like more than 2 or equal to or more than 3, you might not want to make these edge points smoother, but only when the point is connected to 2 neighbors. Maybe that's the curve you want to make it smooth. You might want to omit those points which has 3 or 4 connections to be smoothed. Especially those cases, if you make it smoother, it looks a bit weird. I mean, it's your choice. I mean, you could either ignore it or make everything smooth or make some of the points fixed. That's your choice, but let's make it procedural so that you can choose some conditions. So what I'm gonna do, if you look at the smooth node, there's a parameter called constraint points. So this is where you can use to fix some specific points. If you say fix everything, nothing's gonna be smooth. So if you choose several points to be fixed, you can kind of control the smoothness on specific areas. So let's try to pick some of the points with conditions. I'm gonna use point wrangle to choose where I'm going to fix the point. So one of the conditions I can think of is to count the neighbors, just as I said. I'm going to use neighbor count, this point number, and let's say if the end count is more than 2, let's fix it. Let's try to fix it and see how it looks like. Let's call fix. I'm going to create a group called fixed and place this point number in it. Okay, and on the smooth node, I'm going to say constraint points is fixed, so that those points where you have more than 3 connections will gonna be more straight, more hard. Okay, so that looks good. Now let's go back to the original surface. Then what I want to do next is to apply that smoothed edge information to this original mesh somehow. Okay, so let's do that. In order to do that, what I need to do is to first of all get the I need to know where the position is, corresponding position is for each edges. Okay, oops. So let's get that information first. So this is the original geometry. ln, instead of set point group, I like the syntax group name of group 1 when setting group on the current point. Yeah. I think that's smarter. That's less lines, so yeah, I think it's better. I always kind of forget this syntax, like using attribute syntax for the group. So that's kind of because that's kind of why I'm not using it, because I forgot the expression. Thank you for reminding me. Okay, so what was I? So let's get the point information on these edges. To do that, I'm going to create some additional like ID like integer value to each point before combine and convert it into line. So let's say I'm gonna call this OID. Gonna create an attribute called OID, like original ID, copying from the point number. Okay, so that will make you preserve these OID even if I convert these meshes into line like these. So now I can use these information from the original mesh to search for the specific points. Okay, so give another point wrangle to the original geometry. Now connect this smoothed surface to the second input and copy the edge position, or transfer the edge position. Okay, easy. What you need to do is to look for a corresponding point. Int pt is equal to find attribute val, and you're looking at the second input, the point class, and the name is OID, and using ptnum as a search query. And if you couldn't find the value, it's -1. So if the pt is equal or more than 0, then you are at the edge positions. Now you can get the point positions on this specific point, then copy it to the current point position. Okay. Now I think I am missing something here because okay, I realized that at each point you have two different OIDs in this case. Yeah, I realized that. So that's problematic. I shouldn't probably use OID, but instead maybe just use the positions. Okay. Or maybe something as a different method. Okay, let me think what will be better. Previously in the examples that I created, I think I did use the positions. So right. Okay, so instead of using OID, what I'm going to do, so I have these lines which is not smoothing out yet. So maybe I can get the point number informations from here by referring to the position first. Then use that point number to get the updated positions of the edge from the third input. Okay. So let's do that. So first of all, from the second input, I am going to get the point number, which shares the same positions. So I'm going to use new point on the second input using the current point positions, get the point positions on the second input, and calculate the distance. If the distance is smaller or equal, pretty much equal to 1, I mean 0, that means your point in this current point wrangle is at the edge, the hard edge. So that's when you want to copy the point positions. Okay, so end pause to P. So if D is small enough to 0, then get the actual positions that you want to use from the third input using the same point number. Okay, then copy it to your current point position attribute. Okay. Okay. Looks like I have succeeded. Okay. Now, once you have it, it's also better if you could smoothen out the surface itself as well, because currently the surface is a bit bumpy compared to the edge. So after you have transferred the edge positions, let's give another smooth, and this time for the surface. Okay, like that. So this is just a one round, but already looks better than before. So this is the actual output that I got. Well, I might need to want to do something like about here, but overall it looks fine. Previously it looked like something like this. So yeah, so this is how I made the hard surface. Not sure if this is the similar steps how Saito-san's did, but that's what I tried it out. Okay, and I think you could continuously do the same steps over and over again, like this steps, to make it smoother and smoother if you want. So let me try. You can make a recursive loop by changing this to feedback each iterations by count. Make this fetch feedback, and this will continuously gives you the same operations to the same geometries over and over again, will make you more smoother edges on each part, gives you a bit more updated version like that. Now I do have some problem like these part, maybe those like these part where the edge is really close, getting close to each other. I might want to like merge it to one edge. Now that I didn't do that on the example, for example on those edges as well, but seems like it's better if I do that. Yeah, well, can I do that? If I need to do that, then at some point where I made smooth edge somewhere like here, it might be better if I do a fuse, probably with some threshold for snap distance without actually snapping, I mean fusing. So let's say 0.01, 0.1, that's too much, 0.02, okay, so like that, and that will kind of removes, I mean just delete all the lines in betweens, I think. But the problem is it's not fused yet, and if I just use the fuse without any options, it will like mess up the point numbers, so I don't think I can do that here. Okay, so what I need to do now is to remove the surface which kind of exists here. And I also want to yeah, let's try to remove those faces which are too small. If I can do this with clean, that'd be better. So is this, yeah, something has been deleted, so maybe it's been kind of being fixed. So these edges are becoming smoother, so maybe it's being fixed, but I need to test it out. Let me remove those faces and see what's gonna left. Okay, so nothing here, so seems okay with these faces. Now what about these part? It's a bit more problematic here. I think for these one you might need to do the similar operations that I did here, like assemble, fuse with the class information. Now I think I already have the class attributes, so maybe if I have this fuse with the match attribute equal to class in the end, yeah, that will fuse the inner edges. Okay, now that looks better. Now I am not sure why this is still pointy here. Maybe I have additional geometry somewhere existed. If I continue this loop to 20, still have pointy edge. Maybe I need to think of some other conditions. And this one as well. This is because it's not fusing yet. The distance is a bit too small. Maybe I can increase the threshold here to 0.3. Not good enough. 0.05. Okay. So that's good for these part. Not for these part. Well, maybe I can just ignore it because that's not like the main step that I need to do at current, but let me just check what's going on here. I'm gonna move this point, see what's happening here. Okay. Maybe this is the problem. I kind of need to recreate the group for each loop. This group used to be a pointy group, but this is kept because of the recursive loop. So for each loop, I think I need to reset it. Okay. But nope, that was not it. Is it resetting it? I might need to... Well, actually, the original geometry doesn't have that group. Okay, so that doesn't really matter, actually. So let me check here. So this is kind of not smoothing out. That's because you have, I'm assuming there's more than 3 connections at this point. So that should be the problem. And where does the third line? Where is the third line? I don't see it. Let's move this line a little bit. Okay, there you go. There you go. Okay. And seems like alright. I was hoping this kind of a small like triangle is being deleted with this clean, but it wasn't. What if I move this up a little bit? Nope, it's not gonna solve it. Well, something happened that's because of this. Maybe what I could do, create a measure node and delete meshes that's too small. What is the range here? So how do I know what is too small or not? Maybe I can get the attribute promote and get the median of the area. Primitive to detail. Calculate the median. Change this to med area. Okay, so this is kind of average value. So if the area is way smaller than this average, maybe I can just delete it. Something like if area is smaller than detail, the mid area multiply by 0.001. Okay, how's that? Nope. Probably. Let me check the geometry somewhere around here and try to move this point a little bit. See how it looks like. This more looks like surgery. Okay. Now when I turn this to a curve, I kind of have multiple number of curves here. So there's one curve here, one curve here. So one curve from this point to this point, curve to this point, and curve to this point. Okay, so that's problematic. And okay, so it's pretty why that kind of situations happens with these. If I delete these meshes, okay, so this one doesn't have an inner point right here. That was the problem. And it must be is because of the steps that I added here. Yeah. Let me disable this for now. Go back to we are. Okay. Oh well. What can I do? Not sure. Let me know if you have any ideas. Thing is, I don't want to delete the lines at this point because it's going to be referred with these. I kind of need to know when it loses this connection. Okay. So right here, if you look at carefully, at some point, these points connected together like this. These being kept as a small triangle and starting to mess up. So once this point fixed to this point, maybe other point might want to go to align with these line as well, which happens with these node here. It's pretty hard. Oh well, I'll just skip. I know the problem. Maybe I can go back later to deal with this later. Okay, but in most of the situations I think it will be fine. So this is the kind of a final result that I got. If you want to have more hard edges, you can go back to here, normal threshold, and decrease the value. Then you'll have more hard edges. Like that. Okay, some weird positions, maybe those parts I need to fix, but overall looks fine. And you can also control like the threshold for the fixed point right here. Maybe you can parameterize this part. Let's call this end count. So when it's 0, everything will be fixed. If it's 1, still everything is fixed. 2, just the two neighbors are going to be smoothed. 3, most of the points is going to be smoothed out. And 4, it's more like a wrapped, like rock. Okay, I think I like somewhere around 2 or 3 in this case. 3 is also nice. 2 is also okay. I'll go with 2 for now. Okay. And now I'm going. Let's say I'm done with the hard surface part. Now the next part that I'm going to do is to create some different gradient effect or textures on each faces, on each hard faces, like for these. So let's do that, shall we? Let me clean this up a little bit. Okay, so first of all, what I'm gonna do is to place UVs on each faces. That's the first thing I want to do here. So let's do that. To do that, let's see. Sorry. I am going to use for each connected pieces. And for each faces, I'm going to try to put UVs. And the way I'm going to place UV is like this. Look for the longer edge, longer distance across the geometries, and use that as a maybe U value, and get the perpendicular directions and use that directions as V. Okay, so to do that, first thing first, I need to know which direction is the longer directions and which direction is the perpendicular directions, perpendicular to this longer direction. Now each faces is currently placed randomly in the space, so I think it's better if I just move this perpendicularly to XYZ coordinate first to make it easier to calculate the lengths. So I'm gonna just use boundary node with oriented bounding box options, which will kind of wrap the geometries with smallest area, smallest possible area box, wrapping the geometry with the box which has smallest possible area. Okay, so now that I have this box geometries, I can also output the transform attributes to detail attribute, which is actually the transformation matrix used to move and rotate the box which stands on the XYZ coordinate perpendicularly to this space, which means you can actually use that information to place the surface perpendicularly to either X, Y, or Z. Let's use that. You just need to calculate the invert matrix of this transformation matrix and apply that to the surface. So let's first get the matrix. And calculate the invert matrix and apply that to each positions. Now it's being placed either on XYZ coordinate. In this case, this is placed on XZ coordinate. Now there is a chance that this is going to be placed on XZ, XY, or YZ. Let's test it out. Like these. So you don't know which part is going to be larger, either X, Y, or Z coordinates. So you need to check every X, Y, Z coordinate and then find out which direction is the longest. Okay. So let's do that. What I'm going to do, after I have inverted the geometry, placed the geometry flat on either X, Y, or Z plane, I'm going to get the directions for the U directions and V directions in order to create a UV based on these lengths. So first thing first, let's get the size of the current geometry. I'm going to get the bounding box geometry, bounding box size. Okay, then let's also create an array called sizes, applying all the actually I'm going to convert this vectors into an array just by transferring the X y, and z, in order to compare with the other arrays. In this case, a direction array. So size x is the x directional size, length, in this case, this length here, which corresponds to set x coordinate. Y corresponds to y coordinate, and z corresponds to z coordinate. Okay, now what I want to do is to reorder these array based on the size. Okay, so smaller to larger and get the largest value. In this case, I know that z direction is the largest, but I need to do it automatically. So I need to get that information automatically. So to do that, first of all, I am going to calculate the order of these size array by using argsort function, which gives you a integer array of informations, indicates which one is smaller, which one is larger in these array. Now I can use that information to reorder the directional array like this using reorder function. And now that the direction array is being reordered based on the sizes, the first item of the direction is the smallest, and the last item on this array is the largest, which I want to use it for the u value. And the second one is the middle size, which is going to be used for the v. So u direction is direction third, v direction is direction 1. Okay, and now now I can let's store this informations to this information. Actually, at this point, maybe I can already create a UV value with these informations. So maybe I can use a dot product. Using dot with the at p with u direction gives you a distance. For example, let's say you have like these point, these point, these point, these point, these point, these point, and these point. And currently the direction 1 is, let's say, z direction. And calculating the dot product between each point and z position, meaning you are projecting each point to this z-axis, and then get the distance from the 0 coordinate. And that information can actually be used as UV itself, probably. If it's negative direction, there'll be negative d, negative value. So you have something from negative value to positive value. We don't really know the range yet, but we could guess the range by, we could normalize the range by getting the minimum and maximum of the bounding box. So I think you can do all the steps inside this code here. Shall we do that? Okay, so let's calculate let's call this du, and dv is, shouldn't use this because it's used for the differentiable udist. Okay, dot at p v direction. Okay, now let's normalize these values to 0 to 1 by getting the minimum and maximum informations of the boundary using get b box. Now I also need to make an array for these vectors as well, because we don't know which direction is going to be used for the u and v, so do the similar things that I have here. Max directions array. And do the same reordering for these minimum directions and maximum directions. Oops. So minimum directions, maximum directions. Okay. Now I can get corresponding u minimum values, and I shouldn't use vectors, this is just a float, sorry. Let me just call this mins and maxes. Okay, and so float min u min is direct min's third, float v min is min's first, float u max is max's third, and float v max is min's maxes. Okay, now I think I can use these informations to map these informations. Okay, so the actual u value is fit u destination, u distance. Actually, I don't really need to use dot product in this case. I can just say at p dot. Oh well. Now that sorry, I realized I don't know which direction it is, so I still need to use this one. Okay. So u distance is in between u min and u max. Make it 1 to 0 to 1. Okay, do the same for v. Fit u v distance, v min, v max, 0 to 1. Okay, now that I have two informations, let's apply that as a uv. See what happens. Okay, and last of all, I need to make this back to the original positions. So let's refer to the transformation matrix again and use that to reposition to the original position. refer to the X form, multiply matrix to this position. Okay, and there you go. You are now having normalized UVs on this surface, and the longest direction is being used as a U. The second longest is going to be used as a V direction. And let's see all the other cases, and looks fine to me. Yep. Okay, good. So now that I have UV, it's time I go into a Copernicus to actually create a shader, a texture for each faces with the gradient stippling effect. Stippling effect, gradient with a stippling effect. Okay, let's make this grouped. Okay. Now, one thing, in order to make each face a different gradient value, you need to have additional information other than the UVs. Something, some attribute value which indicates each faces. Well, I still have a class information on each primitive, I think. Yeah, but since this is an integer, and if I want to use this in texture generation, I think it'll be useful if I normalize this into 0 to 1. Okay, just as you do in shaders, I think. So let's normalize these class to be in between 0 to 1. I'll do that by and I need to place that class information to a point attribute. Currently it's in primitive. So first thing first, I'm going to use attribute promote to promote the class from primitive to point. Let's not delete the original. Okay, now it's in the point. Now I know that the smallest one is 0, so I just need to know the largest value to normalize. So let's give attribute promote again for the current point to detail, get the maximum value of the class. Okay, let's check. So maximum class number is 33. So what I just need to do now is to divide each class on the point with this 33, so that you'll get the value in between 0 to 1. Let's just do it on point wrangle. Get the max class value from detail. Apply it to a float, apply that as a float attributes on the point. Let's just call it C. And by dividing class by max class. Okay, let's check. So C is from 0 to 1. Yep. Cool. Okay, now I think I am ready. It's time I go to the Copernicus. Let's also give additional informations like normal as well. Normal direction. And since I am going to use a rasterized geometry node, I'm also going to prepare a camera as well. Okay. Okay, somewhere around here. Now, let's dive in. I'm going to also connect new node called Geo, so that'll be easier to refer to inside of Copernicus. So let's give a new COP network and dive it in. Now this is where you need to be careful because it crashes a lot in my environment. Okay. So first thing first, let's create a simple gradient and put it on each faces without changing the colors yet, without changing the types of gradient yet. To do that, I am going to first of all create a geometry. Well, there's two ways to color the faces using Copernicus. One is to use kind of a post-processing way, get the screen informations using rasterized geometries and put the color information on that to make as an image. Or you could create a material-like approach and visualize it using something like preview material. The approach that I'm using is the first approach, meaning I'm going to get the whole screen informations using rasterized geometries and put colors on it, on top of it, because of the effect that I want to create, something like stippling and change the gradient color for each faces, which is a bit hard to do if we're using material approach. So let's do that. I'm going to create a rasterized geometry and also create a sub import, and I'm going to choose the geo which I want to visualize. I'm also going to create a camera, refer to the camera which I have also created. Okay, which gives you kind of a captured screen image based on the camera positions that I have. Currently the information that I have is only black and white, the alpha channel. I'm going to add several attributes to this. First of all, normal, UV. I could also use depth and additional custom attributes like C, which is mono, single float value. So I think these are the informations that I need. Maybe I could also use something like positions, but let's try to go with these. Okay. Now let's visualize the UV from this output to see how it looks like. So UV looks like these. Okay, a bunch of gradient. Now it's already been gradient, so you can kind of easily imagine how this can be converted into your custom gradient. I think create a ramp RGB, which gives you an option to create your custom gradient value. Let's go with Inferno. And what I'm going to do is to just sample the color from this texture, ramp texture, using these UVs by using sample texture sample. So this is the UV, this is the texture. As a result, you already get these gradient. Cool. Now what I want to do next is to change the gradient color for each faces slightly. So to do that, I'm going to use additional attributes that I created, which is this C value. which stands for the class. So to use this, I'm going to try to use this as a shift value to shift the color from one ramp to maybe another ramp. So create another ramp parameter using different gradient, something like that. And then try to create a shift, try to shift the color from this value to this value based on this C value. Now, unfortunately, there are no node like lerp in Copernicus. It might going to happen in future, but currently not, so I need to use something else. So what you could either use a node style calculation or using OpenCL. OpenCL is simpler, but let's go with the node for now, if I could find something useful. Well, what I just need to do is to first of all multiply this gradient with this C value here. Oops. Now let me check how this C value looks like. Okay, that looks like this. Okay, probably I might need to multiply. I might need to do this. Might need to bring C to the first input and gradient to the second input. Okay. Now let's, but is it, no, nope, sorry, nope, that's not it, that's not it. Actually, I think I need to create two texture samples using different color map and somehow mix those two based on C value. Okay, so what I'm going to do is to multiply the first texture samples with C here for the first texture sample, and for the second one multiply this value with again C but subtracted by 1. So subtract subtracted with 1. So going to subtract the first input is going to be 1. The second value will be C. Now you can connect this to here. Oops. Now it's a problem. That's because the size is not corresponding. Probably need to connect this to here. No, actually not. I just need to refer to the size. Okay, gonna connect it. Gonna connect this to actually that's not a good idea. Well, I don't think I can create a clean network here, so forget about those nodes. I'm gonna use OpenCL instead. Sorry for that. So use OpenCL to color the geometry with these gradient. Okay, so the first input will be the original value with original color value, which could be anything, but that needs to have the specific size, the size of this camera size. So it's better if I have something that corresponds to that size. Maybe I can use this n for the initial value, which I'm going to replace it later. Now I think I need several inputs for this OpenCL. One is UV, which is a UV. Source is RGB. Destination is RGB. Again, you have a color ramp 1, which is RGB. Color ramp 2. Again, this is RGB. Okay, so far I have 4 inputs. The original map, UV, and 2 colors. Go back to kernel. Let's bind these informations. So the source is float 3, the destination is float 3. Bind layer UV, that is float 2. Bind layer col 1, that's float 3. Bind layer col 2, again float 3. Okay, let's connect these informations. This UV, the color. I can just connect it directly to this here. And the second color to here. Okay. Now let's try to show the first gradient value. Oh, actually I need to input the C value as well. So let's create additional input. C, which is a mono. Bind it. C float. Connect it here. Okay. So to get the gradient color from using the UV, it's pretty simple. The color that I'm going to use is this color 1. So just use at col1 dot texture sample using the UV coming from here. UV, which will give you a float 3 value. And try to output it here. Okay. Do the same for the color 2. Color 2 using the same UV and try to output it here. Okay. So both things works. Now it's time to mix the color using these C value. Kind of blend the color using this C. So the final color is col1 multiplied by C plus col2 multiplied by 1 minus C. And if I do that, oops. C, okay. sorry, need to put at before C. Okay, so that is a mixture of a color 1 and color 2 using a class value which is from 0 to 1. Let's look at these shape. And somehow each color is a bit similar. Let's try changing this to something else. Like, yeah, this looks better. So you're having, since the position of each class value is a bit randomish, you have some nice diversity based on the C value here. You can actually create your own custom attributes on SOP network and use that to mix the color as well. But for now, I'm making every surface a different color. You could add additional ramp parameter to this, like third color input. That'll be more harder to decide which color to be used, because you have to like choose between multiple number of colors. So I'll leave that to you for now. Now that I have these informations, next thing I want to do is to have a stippling effect on each gradient. Currently this is a bit too artificial, I mean too clean. But what I want to get as a result is something like this, having some dithering or stippling effect on the gradient to make it more like a, how do I say, picture book like effect. That's what I would like to get here. So let's try that. And that is pretty easy actually. What you just need to do is to make the original, make each UVs for texturing to be stippled and use that modified UV to capture the image. I'm gonna show you by creating a simple like fractal noise value, do the stippling on top using this one as an example. Let's make this RGB, make it smoother, pulling noise, amplitude to 1, element size like these, have some contrast, bigger contrast. Okay, so let's see how I can create a stippling effect in this one. The idea is pretty simple. For each point, I'm going to calculate random directions. I'm going to get the random directions for each point and sample the color at that directions using specific distance and replace the color with that. And just by doing that, you could create a stippling effect. Yeah. The amount of stippling is based on the texture resolution, so the resolution is kind of important here, but let's try that out. So in order to do that, you do need to use a custom script like OpenCL. So let's use that. And OpenCL doesn't have a support for randomness as a default, so you need to import the random functions which is available for Houdini. So let's search for how to use that. Okay. Let me search for it and so currently I'm running the Houdini on Windows, but I am accessing remotely. Using Mac. And this site gives you a whole lot of information about how to use different functions on Houdini, Copernicus, and I think I have some issues with the connections. The site looks a bit weird, but what I just need as an information is what is the library's name for the randomness. So somewhere around here. Okay. Random numbers on OpenCL. So you can use this library here, import random.h. Gives you a whole lot of random functions. Okay, so I'm gonna copy this, and probably the one that I'm gonna use is this one, single seed, to create a float to random value, which can be used to create a random UV direction. Okay, paste that, and let me go back and copy this function's name as well, and paste it somewhere here. Okay. So let's create this random direction, not vector, but float 2. Using vex random 1 2 and using single seed. The seed could be anything, but let's use something like what can I use this? What can I use? I can use the value of the colors. I can use the number of X and Y. Let me go back to the Houdini OpenCL informations, where it shows a bunch of useful informations. So OpenCL for Vex users. There's a page specifically for Vex users, how to use OpenCL, which gives you a bunch of global attributes can be used in OpenCL, such as IX. These one. So maybe I can use this app P, which stands for the pixels or image. So at P should be different all over the places, I think. Current image space of the process voxel. Yeah. So hopefully I can use that as a seed. Let's see. Let me just test this out by outputting the random directions as it is. Oops. Okay. Let me change the bindings. Oops, not here. Signature to UV, source to UV as well. And let's also change the bindings, this here to float 2 and float 2. Nope, still not. Can't convert RGB to UV for source. Okay, so this needs to be 2D. Let's go with this. What else? Static float number, random. Okay, it says it needs to be a float number. You cannot use float 203. Get it? Okay. Right. So it needs to be a number. Alright, then I'll just use RIX plus RIY multiplied by RXS. This should give you a different value for each pixels. Okay, so it seems I got the randomness correctly. So what I want to do now is to make this random direction as a direction to move the current point position a little bit to this directions and resample the color from the source okay, to create a actual color. Okay, so now this one, I want this one to be float 3, so I'm gonna make this back to float 3. Go back to signature, this is float 3. This one is float 3 as well. Okay. Now I'm just going to output black color. Okay. So once I created the random directions, this is the x coordinate and the y coordinate of this direction is in between 0 to 1. So I'm going to subtract this by 0.5 and 0.5 so that I'll have a directions on in 360 degrees. Okay, now you also need to control the amount of the distance you move from the current point position, so let's have some parameters for this. You can set the parameters something right here. Go to binding, move, I don't know, offset, make the value float, precision, node, value. Let's try with 0.05. And time scale, doesn't matter. Okay, so let's import that. Let's bind that information. Or is it already bind? Maybe. You could multiply this by accessing to the offset that I just, oops. Okay, spell mistake. Okay. Now, let's save this. And it's time I'm going to sample the color using the offsetted directions that I have here. So first of all, you need to have the current UV informations to sample, which can be created using IX and IY. The U can be calculated by IX plus 0.5 divided by XRes. The UV value can be calculated by adding 0.5 and divided by YRes. And don't forget the semicolon. Now let's try sampling the color using this UV that I've created from the source, which should give you the same result as the input here. Let's name this col. I'll put it as col to destination. Okay, so currently it's just the same color. Now it's time I offset this UV using this information here. What I just need to do is to add it like this. And now you start to see this stippling effect happens on the edge of the color. And if you increase this value here, say to 1.1, you have more dissolving effect. 0.2, more like a smoking glass. So it's pretty easy. So that's what I want to use in order to control, in order to modify the UV that's being used to sample the color for each gradient. So what I need to do is to modify this UV here with the stippling effect and place it here. So I'm gonna bring this somewhere around here. And since this is 2D and UV value, let's change the binding to 2D. So UV, kernel, flow 2, and flow 2. And this needs to be flow 2. Okay, so connect this here. You're going, okay, well, I don't think that's what I want to have, because this is creating the overall image dissolved. That's a bit of problematic. If you have it here, you're just going to get the blurred image. So that's not what we want here. No, we just want to have a dissolving effect just on each faces, not for whole image. Okay, so what we need to do in order to make the effect that I want, first of all, I need to dissolve the original UV map. This one. Let's make this the texture map. Okay, so if I connect this directly to OpenCL that I've just created, this will create a dissolving effect for this specific map. Now, if I look at the border, it has some problem here. I think I need to fix it. Let's give a little bit more value to this binding value. Okay, so it does gives you a stippling effect, but you are having a problem on the border. That is because when the offsetted UV goes more than 1 or less than 0, it just goes back to the other directions. So we need to clamp it somehow. Clamp the UV value here. You can say clamp to 0 and 1. Okay, well, you still have some problem here. I might need to make this a little bit bigger, a little bit smaller than the 1. Okay, now let's fix it. I think it's float precision issues. Okay, so you need to have some sorts of small values offset. Okay, so this is not good. Probably this is the threshold, the minimum threshold that I can give. Okay, now it looks good here. So the next thing I want to do is to replace this UV value here with using this as a UV map, which you can do that by sample texture sample. Sample the textures here using the current UV, and as a result you are sampling, using the original UV on each faces to sample this modified UV, placed it, making each face's UVs stippled. And now you can replace this here. As a result, you can now see the image, the gradient on each face is being stippled like this. Cool. And that's how you do it. Alright. So that's pretty much it. Now I think the whole setup is being created. You could add several different visual effects to this, but before doing that, let's make a actual crystal shape and apply this gradient color to that crystal shape instead of just using this test geometry. Okay, so going back to where I was creating a geometry, which is this one, I think. Let's create a simple crystal geometry, which is not that hard to create. The step is, first of all, create a simple crystal base shape from the line, then copy it to place it like a crystal. That's it. So how do I do that? Let's create by, let me see. Let me check how I made it last time. Okay, so first of all, I'm going to place the line, the simple line, on top of a sphere to use the omnidirectional normal direction. If you create spheres using polygon as an option, and if you calculate the normal directions, you have a bunch of normal directions, which I think can be used to place these lines as a base for the crystals. Now, I don't want to create the crystals on the bottom part, so maybe I can just cut to get just the top part of the geometry. Okay, so, and I don't really need the face information, just need the point information. So first of all, delete the faces, keep the points with the normal, and just retrieve some of the parts on the top points. Maybe you could use something like clip node on Y direction. Make this go above a little bit up, like that. Okay. And maybe I can use these points as a base point to copy the line to. Now I might want to make the starting point of the line to be on the center. So I can then transform this or scale this point to 0 like that, so the center will be always in the 0 positions. Now I can copy the line to each point. Now the direction is not correct. Let's change the direction of the line. 0, 0, 1. Okay. So this is the base for the crystal. Now currently the length of the line is the same, which is a bit artificial, so let's make it randomized. And also maybe the one that's standing straight, standing close to the y direction might have a longer distance, and the one that's lying might have a smaller length. So let's create that kind of conditions to control the length, and plus some randomness. So point wrangle, I'm just going to create a p-scale value to each point to control the length of the line. So first thing first, based on the y direction, you can calculate the dot product between the point position or normal direction, I guess. Normal directions and y directions. If it's bigger, maybe you can make the length bigger. If it's smaller, maybe you can make the length smaller. Okay. So if you use the dot product, the value is in between -1 to 1 if two vectors are normalized. In this case, there are no negative directions correspond to y direction, so you only get the value in between 0 to 1. So let's see if I can use it as it is as a p-scale. See what happens. Okay, so when it's lying, gives you a smaller value. If it's close to a y directions, give you more lengths. Maybe I want to remap this value a little bit so that the lying crystals could have a little more lengths. So d is in between 0.5 to 1.5 maybe. Yeah. Okay, looking better. And as an additional value, maybe you could also apply some power functions to this just to exaggerate the effect, whether it is at the bottom positions or facing top. Okay. As an additional value, you could also apply some randomness to this using random functions based on maybe p, small ranges between, I don't know, 0.75 to 1.25, and update this d with this randomness. So there is a chance that the bottom, the lying crystals could be longer, the top facing lengths could be smaller, to give a little bit of randomness. Yeah. Okay, so let's say I'm okay with this. Let's create geometry out of these lines. Now first thing first, let's try using polywire to this lines as a base, and probably I could give a little bit of divisions to this, like number of 5 or 6, 5. Okay. Well, I used to play a lot of JRPG, Japanese RPG games before, and I'd see a lot of crystals like in Final Fantasies, and all those games have like pointy like effect. I mean pointy edges on the top, I think, on a crystal. So let's try creating that kind of shape. Now to do that, I'm going to resample the curve, resample the lines, each lines with specific distance. Currently it's set it to 0.1. Not sure if that's enough. It's a bit hard to see where the point is. Let me increase the point size here. Is it increasing? I don't think so. Yeah, well, it should be, there should be a point. I mean, it's a bit hard to see here, but there is these lines. I think it's because of the remote desktop that I'm using. Okay, well, let's give a little bit more distance. A little bit more, like 2.5. Okay, so now that I have these divisions for each lines, I could control the p-scale for each point to control the pointiness of each crystals. Okay, so what I do, the last point should be 0, I think, in order to make it pointy. Otherwise, for the other points, maybe I can control it using some ramp parameters. So let's go to a curve. Let's promote the curve view attributes for each lines, and I'm gonna control the scale for each line using point wrangle. So let's control the p-scale by accessing to curve view, using it with the ramp parameter. Sorry, ch ramp. Replace it. Okay. Now, currently it goes from 0 to 1, so it should be the other way around, but let's check. Go back to the polywire, multiply wire radius, multiply by p-scale. Oops, spell mistake. Okay, it's not what it should be. Should be something like this. The endpoint should be 0. For the other point, you can control as you wish. Maybe could be like these, having more like I don't know, skewed crystals. And you could also increase the base thickness here. Maybe it's too thick. This should be parameterized later. Okay, so let's say I'm okay with these. So that's, let's say this is the base shape for the crystals. I can now continue, can now connect this to where I was using the function, was using process to make it hard surface. I mean, this is already a hard surface, but it might be cool if you have some crack effects on each faces. And automatically, I think it will give you something like that. Let's see how it goes with the hard surfacing process. Now, has some problem here. Maybe you might need to increase the shape, overall shape of this one, because previously this was the shape that I was using, so the size is a bit different. The remesh size is different. So let's try to scale this up a little bit to match with this say face, this rock face here, somewhere around here. Well, still losing some geometries here. Okay. This is not really interesting. So, what I would do, because this just looks as the original shape. So, to make some noises into this geometry, I am going to first of all convert it into VDB from polygon. Let's make this 1.6 scale. Convert this into VDV. Have some resolutions to this. Okay, and make this back to polygon. Convert VDV to polygon. Add some adaptivity to reduce the number of points a little bit. And add some mountain node to slightly shift the geometry, slightly offset the geometry, add some noise to this geometry. That's too much. Amplitude should be smaller. the element size could be bigger, or I don't know, like that. Let's make this a little bit bigger. Okay. And probably I might need to make the touching point a little bit thicker. Okay. Alright. So let's try with these. Okay, well, start to have some interesting how do I say, the cuts. Now I might also need to control the threshold for the normal. to see which value looks the better, as well as the remesh edge size could be better, smaller. Yeah. Okay, going back to normal. Yeah, starting to get some details here and there. I think I like it. Okay, looks good. Looks good. And the final geometry looks like this. You have UVs on each faces. You have some cracks here and there. And moreover, it's more or less, looks like a crystal shape. Okay, and if you go back to the Copernicus, you should be having this crystal shape. Now it's based on the camera view, so let's move the camera to fit this geometry inside the camera. Let's change the camera size to square view. Like that. And going back to Copernicus, there you go. Oh, nice. I think overall I like the effect that I have here. Now, other things that I could try is to add some shadings to this graphic, such as the shade based on the depth or based on some lighting. Maybe that I can add as a post process to this image. So for the depths informations, I already have it from this rasterized geometry, which is called as intrinsic depth I information. If I show that, it's more of a grayscale image, which shows how much it is far from the camera position to the surface. Currently it looks like black and white, so let's remap this to show the range to be more like a grayscale from the depth, from the farthest point on the surface to the closest point on the surface. You can use remap to change this input minimum and input maximum. Let's increase the input maximum to see. Okay. Alright. So what I want to do is to make the front side close to black. So I need to increase this input max as much as possible until it gets to black color at some point. 20, 30, maybe. Actually, maybe I needed to input input minimum to make the front side black. Okay, and for the input maximum, I can control it to see the farthest point to be white as much as possible. So something around 6 maybe, and this one 6, no 4, 3, yeah. So let's say I'm okay with 3 to 6 the remap value, and then it will be remapped to 0 and 1. Now I want to use these value as a shading value Maybe I can increase this a little bit more. No, not this one. 2.7. Yeah. Okay, so to use this as a shading value, what I could do is to invert it. Now you have a father value to be grayscale and grayish value, and front side to be white. So maybe I can change this value a little bit more to make the father side blacker, front sides whiter. Okay, like that. Now, to make it as a shade, to use it as a shade, it's easy. You just need to do a blending between the final color value with the shading color. So when you are far away from the camera, when this point is far away from the camera, it's darker. If it's close to the camera, it's lighter. You can try different types of blendings: overlay, soft light, hard light, dodge, burn, durations on luminosity, and so on. Now I'll go with the multiply, and now overall value is going to be a bit darker. So what I can do is to do another remap here and increase the output maximum value to something a little bit bigger than 1 to make the overall value a little bit lighter. Maybe this is it. Maybe it's overall it's a bit too darkish. Maybe I can control this here. Yeah, somewhere around here. This is the original image. This is the blended image. Not so much of a difference, but just a few point differences. Okay, now I'm also would like to apply some time based parameters to how the gradient changes to make it a bit more nicer, to more interesting. I want to change the color effect by changing the C value that I'm using in this OpenCL. Where is it? This one. So by updating the C value based on time based value, I can I think I can see these crystals like running different colors on time. So let's do that. You can do that by check include time, which then you can access an attribute called at time. This is a second value, second based value from the first frame. So if you have 240 frames with the 24 frame per seconds, you have 10 seconds, right? So that means if you divide this time by 10, from the first frame to the end frame, you get from 0 to 1 as this value, for this value. So let's add C with this value and then create the modulus with 1 so that you can kind of loop the C value from 0 to 1 for in order to change the color. Now let's see what happens. So I'm gonna replace this C with the variable value. See what happens if I play it. So it is changing, but it's changing pretty suddenly. That's because if you go if the C value goes from 1 to 0, just switch from this value to this value. So to make the change more smooth, I think it's better you use something like sine functions together with this timeline. So sine time 10 seconds multiply by pi multiply by 2 will give you like a wave value in between -1 to 1. We're using these frame values. Now let's remap it to 0 to 1 by adding 1 and multiply by 0.5. Okay, so this will give you the value in between 0 to 1. And now you can add to the original C and let me think. You can add to the original C and well, actually you shouldn't do that, but you should offset the time for the sine value using the current C. So current C multiplied by pi multiplied by 2. Okay, should give you the offset for each space. Now I think it's the phase gradient is changing the color over time. It's make the range a bit smaller, like 60 frames, and in that case that's 2 seconds. Like that. No, that's not 2 seconds. 2 second 60 frame 72 and make it 3 seconds. Okay, I wonder if I can access to this fend function, fend variable here. Hopefully I can. That will give you a second, eh? Okay, this is more like it. Now I can easily change the frames. Alright. Now, that's pretty much it. You can now do whatever you want with geometries. Maybe you can also rotate it. And it will be rendered with an optional setup that I created using Copernicus. The gradient shading using stippling effect for each faces with different colors. Alright, so that's pretty much it. Let me know if you have any questions or feedbacks or anything. If not, I'll just end this live. Here. Make some Vellum tutorials. Oh, let me know what kind of Vellum stuff you want to know. Okay, so if I don't get any questions, I'll just end this, but let me clean the setup and end this live. I'm gonna place all the parameters that I can change to the single node so that it will be easier to control later. Create a null node called controller. Place some parameters to it. So in terms of the shape, it could be anything, so I'm gonna leave it to your choice how you choose the geometry. Now the important stuff, remesh size. X strip S. Okay, this normal cusp angle is also important. Okay. Again, additional remeshing, which could be calculated from the original one, but well, let's just have it. Final remesh size. Thank you for the feedback. Now, do we have any other parameters here? This one maybe. Okay. This could also be parameterized, but I'll just leave it. Snap distance maybe. It's a bit hard to control. An interesting OpenCL exploration could be to make stereograms. Interesting. Yeah, stereograms. I tried it on Bex a few years ago, I think. Doing it on OpenCL makes more sense, I think. You could also control the number of iterations. Let me also know if you guys are having any thing for a topic, for some interesting topic. I'm always looking for a topic, but kind of out of my stock. Okay, this is pretty automatic. Okay. And if you go into the OpenCL, it's pretty much automatic. Good thing is that it didn't crash this time. Not sure why. I could... What can I... Okay, I think I can have this stippling offset value as a parameter. It goes from 0 to 1. That's too much. 0.5. Okay, I guess that's about it. Let's see if I can control it. First of all, shape. Remesh size. Or edge threshold, controlling the hard surface. And neighbor point gives you a whole different look. Number of iterations. Stippling. So 0 gives you a really smooth surface. Higher value gives you more rough surface. Yep. I overall think it looks working. Okay. Hi Alan. I just did an implementation of k-means cluster algorithm to approximate a 3D volume with 2D images. First in Vex, then OpenCL. Could be interesting to show something similar to for Vex OpenCL. I don't mean to do this exactly, just an example to do the same in Vex and OpenCL. I see. Yeah, to compare the speed differences, something like that. I mean, I haven't really touched OpenCL in SOP context. I'm just trying this OpenCL in Copernicus. So maybe doing this in SOP OpenCL might also be interesting. I mean, once I tried using a, what was it called? Gray-Scott algorithm. Kind of a reaction diffusion, one of the reaction diffusion based algorithm based on using Vex, and ported into OpenCL to see the differences. The speed difference was pretty high. I mean, OpenCL was much faster for sure, and it was a bit harder to write as well. That's true. Kind of a how we can overcome some difficulties with like array access, matrices, and so on. If we can come up with some standardized way, could be pretty useful to go from Vex to OpenCL. Could it? Because for the higher calculation, yeah, it is much efficient using OpenCL for sure. Yeah, let me think about it. If I have some good topic for that. Well, thank you for the comment. And I guess this is it for today. Well, next week I might not be able to do the live stream because I'm kind of offline, not connected to internet next week, so maybe I might not be able to do it. So probably 2 weeks from now. The next live stream is going to be 2 weeks from now, but hopefully I'll be able to do it. Okay, so that's it. Thank you very much for all the comments, all the likes. I will upload the file that I've created here to GitHub. You could access to the file from the video description page once I upload it. Okay, that's it. So thank you very much for coming, watching. Hope to see you next time. Night.